blank, comma, then blank. Also just known as an if-then statement. So our part that has to be met is if this part happens, then we can allow this part to happen. So if it's been 10 minutes of class, then you can sign up for a bathroom pass. Okay. In my case with the house, it was if they get a house inspection, then we'll buy the house. Okay. The if part here is called the hypothesis. When have we heard that word hypothesis before? And what other class? Science. When do you make the hypothesis? After? Before. You come up with your question, and then you come up with your hypothesis. Oh. What comes at the end? Conclusion. That's after you do everything, you go back and you say, yep, this is what happened. Conclusion. So we have the if, the hypothesis, the before, and then our conclusion, which is after. Okay, we're going to make one little note here. So if you want to just do a little bullet or a star or something, we always assume the hypothesis happened. Now, this is different than the hypothesis in science. In science, your hypothesis is kind of like a guess, right? In this case, when we talk about hypothesis, we're talking about a condition, something that needs to happen first. So once this happens first, then the second thing happens. All right, we're going to do 4 examples today. In our examples, if you want to write the directions, you can. If you're this is a long directions, that's fine. We're going to identify the hypothesis and conclusion. And then we're also going to determine the truth value. All right, this is the part where I'm going to use my colors. So if you wanted to use highlighters, you could, or if you wanted to grab 2 colored pencils. I'm going to use orange for hypothesis, and I'm going to do a box whenever I see the hypothesis. And then I'm going to use blue for conclusion, and I'll underline the conclusions. Just that way it helps us kind of identify what's happening a little bit sooner. Okay, if you're using a highlighter, you can just highlight. You don't have to box and underline. You could just highlight it in those 2 colors. It's your choice on how you want that. We're going to do 4 examples. So it is kind of a lot of writing because we're writing statements. All right, so number 1. If 2 angles I'm going to do one that's geometry based first, I guess. If 2 angles add to 90 degrees, comma, then they are complementary angles. Alright, phones are still away. I'm noticing a couple sneaking out. So keep those away, please. Thank you. Alright, what do we got here for our hypothesis? What is our beginning part of our statement? What is the hypothesis? Good, two angles. So when we say the hypothesis, we don't actually include that word if, which is exactly what you did, Jose. So two angles add up to 90 degrees. That's my hypothesis. I'm using a box for that one. If you're using a certain color, you can use that color for hypothesis. You can also put an H above it so we know it's hypothesis. And what is our conclusion? We see two angles add up to 90, so what can we say about them? They are complementary angles. And I'm going to just underline that one. That's our conclusion. So now we need to decide if this is true or false. So if we're not sure, we can go back to our envelope from a couple lessons ago. Let's see what complementary angles are again. Oh, whoa, that was really cool. I pulled it out right away. So complementary angles, say two angles that have measures adding up to 90 degrees. So if they add up to 90 degrees, can we say that they're complementary? Yep, that's true. So our truth value is true. Hi, how are you? Good, it's good to see you today. We're about halfway down our notes, if you want to start. Halfway down the page. That's what I meant. All right, we're going to do 3 more examples. Cool, just dropping stuff. Awesome. All right, number 2. Number 2. If yesterday was the 30th, then today is the 31st. If yesterday was the 30th, then today is the 31st. All right, so let's start by identifying our hypothesis and our conclusion. What is our hypothesis here? Good. Yesterday was the 30th. So we know that happened. Yesterday was the 30th. Was yesterday actually the 30th? No, yesterday was the 22nd. But in this situation, we're putting ourselves in a position where we can say, yep, yesterday was the 30th. What is our conclusion? Today is the 31st. So even though in real life, yesterday was not the 30th, when we determine this truth value, if it's true or false, we're imagining, yep, it happened, yesterday was the 30th. That's a for sure. So if yesterday was the 30th, does that mean today is for sure the 31st? I'm seeing no's. Why? Yeah, it depends on the month. Okay, so false. If yesterday was what's a month that only has 30 days? What's a month that only has 30 days, not 31? Does anyone know? June? Yeah. If yesterday was June 30th, June only has 30 months. Oh my God. Words. June only has 30 days. So this hypothesis is true. Yesterday was the 30th. But in this case, if it was June 30th, what's the day after June 30th? Yeah, today is July 1st. So it still has to agree with that first part, that yesterday was the 30th, and then today is July 1st. Some people, they want to go to February here, and they're like, well, February only has 28 days. But does that apply to this if it's February 28th? Then the next day is the 1st? No. We have to have something where it's the 30th. Yesterday was the 30th. Now today is not the 31st. It's different than that conclusion. Today is July 1st. We could have also used September, November, not December. I don't know. Months. Cool, we got two more. Number 3. All right, 3 and 4, we're going to do these a little bit, different's not the right word. But these conditional statements don't always come in these if-then forms. They don't come nicely for us. Okay, so number 3, I have just this math statement. 6 plus 4 equals 10. Six plus 4 equals 10. So to start off with, let's write this in an if-then statement. So if, what's the first part of our statement that we would start with? If you add 6 plus 4, okay, or if you do 6 plus 4. Do you want to say if you add 6 and 4, or if you do 6 plus 4? Add, okay. If you add 6 and 4, then what? Then it will equal 10. Ishmael, put away your phone. Abdi, put away your phone. Put away your phone. Ishmael. All right, so what is our hypothesis? What's our first part? We add what? 6 and 4. So there's our hypothesis. So we add 6 and 4, then what? It will equal 10. So we need to decide if this is true or false. If it's false, we have to come up with a counterexample, meaning some time where it doesn't always work. So if I add 6 and 4, is there any time where my answer won't be 10? Are you sure? No, 6 plus 4 in this universe is always equal to 10. You put it in your calculator, will you get 10? If I put in my calculator? 10. Yep, all calculators. Okay, so in this case, it would be true. I was boxing my answers, and now I'm not. Which is going to drive me nuts, but that's okay. All right, last one, number 4. How are we feeling? Kind of getting it? Okay. This is the one that kind of blows everyone's mind. So take a moment. Take a breath. First off, realize that you know everything up to this point, so don't panic. Okay? All right, number 4, everybody would be 2 feet taller on Saturn. Everybody would be 2 feet taller on Saturn. All right, to start off with, we're going to put this in an if-then form. That way it's easier to decide what our hypothesis is and our conclusion. It's not an if-then form right now, but this is a conditional statement. We can write it in if-then. So if, what's our first part going to be? If what? Good. What comes first, that we're 2 feet taller or that we're on Saturn? On Saturn. Okay, so if everyone was on Saturn, then what? They would be 2 feet taller. And you could change that everyone part, so you could say, like, if you were on Saturn, then you would be 2 feet taller. Or if people were on Saturn, then they would be 2 feet taller. That everyone part is a little bit, like, that could change. So what's our hypothesis? Everyone on Saturn. And our conclusion? They would be 2 feet taller. All right, what do we got here? Is this true or false? True? Neither? It's got to be true or false. It's true? What? You're right. Our bodies might change. Do we know that for sure? It's a hypothesis. So if we're on Saturn, we have to assume that that part is true. So remember back on number 2, when we said yesterday was the 30th, we had to find a day where it was the 30th. So we said June 30th. That moved to July 1st. So we need proof. We need some sort of counterexample. Do we have anyone that's been on Saturn before? Not yet. Okay, maybe in 20 years from now when your kid's doing their math homework, you're going to be like, oh, back in my day. Okay, but right now, do we have any proof of anyone being on Saturn? No, so we don't have a counterexample. Maybe we would be 2 feet taller. We don't know. So it's kind of like that idea of that you're innocent until proven guilty. This is true until proven otherwise. Even though if it feels silly, we have to say it's true. Okay, so we have to say it's true because there's no counterexample. There's no proof. We don't have an example where somebody went to Saturn and stayed the same height, or maybe they shrunk. So that's kind of our note about this one, if you want to do a little note. If the hypothesis is crazy, or the hypothesis isn't true, or the hypothesis is crazy, we have to say it's true. We need proof saying it's false. So if the hypothesis is crazy, overall it has to be true. If it's false, we need a counterexample. We need to show proof saying why it doesn't work.